Very good morning to all. I think we will continue what we are left in the last lecture. So far we discussed about general engine operation as well. Then we discussed about the transmission types. We will continue with the ray diagram as well as the gear ratios and the problem. We will do one problem and also we will discuss the design procedure for a automobile gearbox aspect. Okay, I will continue with this spade ray diagram or with the geometric progression. I am sure you have seen this earlier also. You can see here the x axis gives the vehicle speed. You can see this is the vehicle speed and engine speeds in the y axis. As you are aware of that, this is your N max, the maximum, the speed limit which the engine should operate, and this is your N minimum is the minimum speed where the engine operates. This is the range. Within this range the engine should operate. Okay, and you can look at this graph. This is given for this is the first gear V1 and this is second gear, third gear, fourth gear and fifth gear. So when you operate this this type of gears, I mean gear shifting, the vehicle speed increasing. Okay. At the same time, the engine must be operate between the N max and N minimum. Look at, so this is the speed for the first gear operate up to 2000, sorry, up to maximum limit, right? From here, the moment you want to change the gear, what do you expect? Its vehicle is operating in first gear. I want to shift to second gear. Then I must drop the speed of the engine to the minimum speed. That is the starting speed. Then as you are operating, this should go to again maximum to for engine operation. Now I want to shift to second gear to third gear. The speed should drop down to the N minimum, and while operation it should go to the maximum. So like that it goes ups and down as you shift in the gear, right? Finally it forms as a sawtooth profile. You could see that, right? And very interestingly, okay, you have a large gradient, I would say large gear ratio in the first gear itself. You could see the huge thing. As you move on to the higher gear ratio, very closer range. Okay, this is for the geometric progression. Already I have discussed about if we have a progressive or logarithmic, what happened to minimum speed? It changed, right? The gap is narrowed down. As increasing shifting, it should narrow down. So that's what we have discussed. This is about the ray diagram for geometric progression. Now I'll move on to the gear selection. So as you are aware of that, we always have the first gear, then the other gears. We are talking about the first gear, which normally talked as a large gear ratio. You have to choose the larger gear ratio such a way that to meet high gradability. The moment I say high gradability, that is the lowest speed, right? So when you have a lowest speed, should have a maximum torque. When you have maximum torque, easy for me to move into the uphill, right? Uphill where you would need more torque. When you even using flyover, a bridge, moving up, you have to have a high torque. So with that concern, you should have a high gradability in the first gear. The second aspect, it should give you good acceleration capacity and low work friction in the clutch during the launch. Obviously, if the higher friction is, starting will be difficult. So you have to have a low work friction at the beginning of a first gear and good creep capacity. Early shifting 1-2 has a negative effect on drivability. The slip limit may be possibly exceeded. Sometimes slipping will be exceeded. So the moment you try to engage with the clutch, you may not be able to hold it also. So that is also you have to take in care of. the top gear ratio increases at the equal speeds. That is also you need to maintain. This is typically for the first gear, which is nothing but larger gear. When you move on to the low gear ratio for the highest gear pair, overdriving, right? Overdriving means if you move the vehicle speed more than the engine speed, it's called overdriving. The overdriving lower the speed and the fuel consumption at constant speed, that you should take care of it. The gear ratio decreases at equal spreads for the second, third, fourth and fifth, and obviously as you are aware of that, higher the speed, the traction forces will be lesser. Such way you have to maintain the gear ratios, that is also there. So these are the area we have to pay attention before finalizing the gear ratios. You could see this is a typical example for 4-speed gear ratio. Okay, you can have either a close range and the wide range, right? And look at the first gear. The gear reduction is quite large, either the close ratio or the wide ratio. As you move up in the gear aspect, the ratio gradually decreases. Okay, the gradually decreases for the closer ratio. The wide ratio also same. The only difference is closer ratio usually for a passenger car, because you have to consider the traffic also, right? You also consider traffic also, that is also very important. Whereas wider range used other than the city driven vehicles. This is a typical example for 4-speed, and you could see another one for the 5-speed gearbox. Okay, again we have 3 different range. We have a close ratio range, wide range and the middle one. In the close run, it start from as high as possible 2.95:1, then decreases, and very interestingly that is follows for other the mid range and the wide ratio also, whereas the 4th gear maintain same as the engine speed. Okay, by doing that, the advantage is you can eliminate one gear, right? A pair of gears you can eliminate and reduce size of the gear and reduce the mass of the gear, overall improve fuel consumption. And usually the reverse gear ratio should be equal or lesser than the first gear. You can look at here, this is 2.95:1, here is 2.76:1, 3.35, 3.15, okay, then 3.97 and 3.0, usually equal or lesser than, you do not want to have beyond that for safety and avoid any catastrophic failure during the reverse aspects. Okay. Now we will do a problem. This is 6th problem. Already we did a 2 problem. I gave 3 problem as a homework. Now in the gearbox, this is the 6th problem. A transmission system for a vehicle is to have an overall bottom and top gear ratio of 20:1 and 4.8:1 respectively. If the minimum and maximum speed at each gear changes are 2100 rpm and 3000 rpm respectively, in that case determine the following: the intermediate overall gear ratio, they are asking about intermediate overall gear ratio, and also the intermediate gear box top and bottom gear ratio, that is also you have to find out. Okay. Is the problem is clear? They given the overall gear ratio of the gearbox top and bottom 20:1 and 4.1. The speeds are also given 2100 rpm and 3000 rpm respectively as a n minimum and n max. Okay. And we have to solve it. Before that, I just wanted to introduce or recollect. I mentioned that Ig is a gear ratio, right? Ig is the gear ratio, is the ratio between what happened, what is the ratio between the gear ratio? Engine speed by gear speed, right? Engine speed by gear speed, this is the one. Then you have a I final drive ratio, right. Again that is from the wheel speed, right, wheel speed and gear speed. Then IO is nothing but overall speed ratio, right, or else IT is overall total drive ratio. Either way is overall or total drive ratio is a multiplication of IG into IF, okay, in turn NE by NG into NG by NW cancel out. Then overall ratio is the ratio between the engine speed and and your wheel speed. This is what already given, okay, we have discussed about this, yeah. Okay. Now I want to give some information. In machine tool gearbox we had called step ratio, a step ratio psi, right. What we got, remember, n max n minimum, okay, equal to psi power of n minus 1, where n equal to number of speeds. This is what we did, and this formula is applicable only for speed aspect, right, whereas the problem they given as a ratio. So there is a slight change in the equation which I am going to explain now. I am going to explain. So when speed, right, I am talking about wheel speed for the first gear aspect. Wheel speed NW, okay, when engine is on high limit speed, right, high limit in the first gear, I am talking about overall ratio, IO, this is I, this is the first. So normally you know that your NW equal to what happened, NW equal to N max, right, N max your overall gear ratio for the first gear. Again wheel speed, remember what happened when you want to shift the gear from maximum to minimum? I am operating at the moment first gear, so it goes to maximum. The moment I want to shift to first to second gear, the engine speed should drop to minimum speed, right, okay. So I want to know about the wheel speed when engine is, right, when engine is on low limit speed, right, low limit in the second gear. Which is nothing but IO overall speed ratio 2. So what do you expect? NW equal to, here the moment you shifting first gear to second gear, my N max should drop to N minimum, yeah. IO 2, okay. We are talking about wheel speed. Technically the vehicle speed should be equal. When you shifting first gear to second gear, the wheel should be remain, because of they are in the rolling direction, they are rolled. Your radius also fixed, right. So if you equate the equation A and B, right, we will get N max rearrange. When you rearrange N max IO 1, okay, N mini IO 2, that leads to, right, IO 2 equal to N mini N max into IO 1. This is what happened, okay. This is what happened. What I am going to do, for my convenient, okay, for my convenient, I will choose K is the similar to step ratio is n minimum, n max, right. I will assume that let K equal to. So, if you I rewrite again IO2 equal to n mini, n max, right, into IO1 is nothing but K into IO1. Okay. So, this we know that if we follow for other speeds also, similarly for other speed, right, IO3, right, would expect n mini, n max, everything I want to bring with respect to IO1. Okay, this will be IO2, but I want to make it as a IO1. If I do, what happened to my K value? Substitute. I know IO2 here. If you substitute this one into here, what happened to my K? It will be squared, right? It will be squared. So, it will be IO1. Similarly, IO3, now IO4 we are talking about because of n mini, n max, okay, into IO3, that should be K cube, right? K cube IO1. How about speed, fifth speed? This should be IO fourth speed, K4, right, K4 IO1. So, if this is similar to what happened, this equation, same as what we got it, only difference is here is reverse, n minimum by n max, that is what you are getting. If you rearrange, right, I will rearrange for this is for geometric progression, right, talking about 5-speed gearbox, generally it is for 5-speed gearbox, right. So, IO2, IO1, right, then IO3, IO2, IO4 divided by IO3 and so on. When you do that, it is a ratio, right, and you rearrange your IO5 by IO1, right, it should have a K n minus 1, the same as the things, where n equal to number of speeds in the gearbox for automobile gearbox, okay, number of speeds. And interestingly, this would be what happened, IO5 is that top, right, that is a top speed, that is a top. So, we can rearrange IO top speed, IO bottom speed, right, it should be K power of n minus 1. So, this is the equation. Remember, there is given the individual speed, here we are talking about as a ratio. When you have as a ratio, the formula changes slightly. Yes, it is overall, it is overall transmission ratio. Okay. Look at very interestingly, how are we going to fix the final drive ratio? Still we do not know the answer, right? How are we going to fix the final drive ratio? I am going to explain in a minute now while solving the problem. Okay. So, now look at the problem. What we have? We have n minimum. N minimum is given 2100 RPM. Okay. That is given. N max is given what? 3000 RPM. Yeah. N max is given 3000 RPM. So, what is the K value? 2100 by 3000, that should give me 0.7. That should give me 0.7. So, what is the first problem? The first thing we need to find out the overall ratio. Top is given, bottom is given. What is the top value? Top wall is given what? 4.8:1, that is the top value. The bottom value is this 20:1, both are given. So, now we need to find out individual overall speed ratio for each gear ratio, for each gear, right, overall ratio, overall final drive ratio. Okay. The first, we know that I equal to 20:1, fine. For second, right, it should be IO2. When you have second, IO2 means K into IO1 into K, that is what happened. Already we know what is the K. IO is 20, K equal to 0.7, that should give me 14, right, 14:1, 14:1 for second overall ratio. Now, when we do for a third, IO3, right, this should be IO1 into K square, right, should be K square, isn't it? 20.7 square, that should give me 9.8:1. Now, we will move on to the fourth, IO1 excuse me, cube, right, 20 into 0.7 whole cube, right. What is the value you are getting? 6.86 into 1 is to 1. Fifth gear, IO5, okay, is same way, should be K power 4, 20.7 power of 4, that should give me 4.8:1, okay. Now, we have overall drive ratio. So, as given in the problem, this is your top, am I right? That is your top, and this should be your bottom, or no, it is vice versa, it should be vice versa. This is your bottom, okay, this is bottom and this is your top speeds with respect to tube, okay. Now, the second thing is we want to identify the gear ratio of, I am talking gear ratio of each gear shifting, first, second, third, but we do not have final drive ratio. How will you do that? How to find out the final drive ratio? Remember the formula, your Ig equal to what? Ig equal to engine speed by your gear speed, right. Your If equal to your gear speed by wheel speed, whereas IO is given is Ig multiplication If, nothing but Ne by Ng, right, Ng by Ne. So, what are the information do we have now? What information do we have from this problem? We know IO for individually, we know IO individually, right, and we need to find out individual Ig value, that is what we need to find out. But do we know about the If? The clue is given, whatever you have a top speed, right, it is a 4.8:1, that would be your final drive ratio, okay, that would be your final drive ratio. So, in fact, if you solve it, I want to understand Ig1, right, Ig1, IO, right, IOI, right, by If. What I said, this should be my If, final drive ratio, it's a fixed one, right. So, when you do that, 20 by 4.8, what is the value you are getting? 4.166:1. Your Ig2, IO2 by If, okay, that should give me, what is the value? 14 here, right, 14 by 4.8 give me 2.916 is to 1. Okay. How about IG3? IG3, just make it here. IO 3 by IF, right. So 9.8 by 4.8 should give me 2.042 is to 1. Then my IG power 4, right. Once again, IG 4 equal to IO 4 by IF, same way 6.86 by 4.8 should give me 1.429 is to 1. Okay. And my IG 5 4.8 by 4.8 is give me 1 is to 1. Now, are you able to follow it up now? Initially, the top and bottom speeds are given, similarly overdrives are given, but we do not know what happened in between second, third and fourth, that we need to find out. And not only that, we need to find out the final drive ratio. Through final drive ratio, we need to find out the individual gear ratio. This is the way you need to know that. This is the way you have to solve it. Right. Any clarification on this regard? This is good. So, look at, can you look at the very closely? This is the wide range, right? First gear is a very wide, very high gear reduction, 4.166. Right. And if you look at the higher speed, I am talking about between 4th and 5th, this is 1.429 and this is 1. Very close range, right? They are very close range compared to your second, third, right? 4th and 5th gears are very close range. And as said in the earlier slides, first gear you should have a high gradability. The moment you have high gradability, the reduction will be very large. Okay. Please understand that the purpose of the gearbox to reduce the speed from the engine speed. Okay. So, that is what we are doing, and please aware of that. When I discuss about the sliding mesh constant, I will tell you. In the video also I have explained that when the motion comes from the engine, from engine to flywheel, flywheel to clutch, immediately you have speed reduction to the lathe shaft. From there again we further reducing the speed, first, second, third and fourth. After fourth gear we are increasing the speed, okay, that to the engine speed or slightly above. If 4 speeds, maximum to the engine speed. If you have 5 and 6, you can go to beyond the engine speeds, called overdrives. Yeah. Okay. Now we will go. Now actually we will going for the proper automobile gearbox design. This is similar to the machine tool as we discussed, but even then the steps involves. Initially you need to understand about the step ratio, gear arrangement and number of stages. Second, construct a ray diagram, draw the layout for a kinematic diagram aspect, calculate number of teeth, then find out the gear module, right. We are talking about, as a design engineer, no information is given, okay. You know only the engine specification. Normally in automobile gearbox design, we will fix the engine, power, torque. Based on the power and torque, we are going to design a gearbox. In your UG course, normally module is given, power is given, right? Then you do the calculation. But as a design engineer, you have freedom. You have to select the material. You have to design the gearbox. You have to design your shaft, bearing selection. Everything you have to do it here. No information given. Only I know engine specification and the size of the vehicle and vehicle weight, those information given. From there, how are we going to design a gearbox? Okay. So, in fact, these are things we are going to look at: shaft design including shaft material, bearing lubrication selection, power losses calculation. Finally, we have to find out do the design for keys, gearbox design as well as mounting also. That is why this course is called design of mechanical transmission systems. We are not doing as a component, but as a system, holistic approach. Okay. And if you look at this is a constant mesh, you can see that. Can you tell me where is the input, where is the output? This is your input, okay. This is the input coming from the clutch shaft, right. Can you see that directly reduce the speed, this is bigger gear. The moment you have bigger gear, the size will be reduced, isn't it? So, this is the reduced, right. From there, it will move on to the other gears. You can see that this is your the first gear, right, and this is your second gear, you can see that, and this is your third gear. What about fourth gear? Where is the fourth gear? Probably this is attached straight away to the input shaft, that is a fourth gear thing, okay. And you can see this is again constant mesh gearbox, only difference is the selection mechanism different. You can see this is selection mechanism, which is a synchro mesh, okay. The synchro mesh also working principle same as the constant mesh, because the gear you have bearings, on top of the bearings gears are rotate very freely, whichever is gear is engaged, only that gear will have a load or power transmission. The remaining gears are freely rotated, okay. If you look at this again, this is the input shaft, right. You can see the reduction here, the power transmission comes here, then this is your lathe shaft. From there you will have a motion to the your output shaft, and this is your gear selection mechanism, okay, gear selection mechanism. I think I am going to have a couple of slides, okay, and look at this. In the difference between the machine tool and automobile gearbox is, in the machine tool gearbox you can make it bigger, whereas in automobile you need to have a compact as possible, as small as possible. That can be achieved if I have a riveted gear train. The reason is, by doing that, this is my input shaft, right, input shaft IP, and this is my output shaft. If they are collinear, you can see that they are collinear, right, they are collinear. So, what happened? I don't need to have another space, right. So, I can make it even more compact, right. And one more thing is, in automobile normally you will have a problem with the center distance also, okay. They will say that my gearbox need to be this much height, that means your center distance fixed. So, you have to work based on the center distance and do the entire gearbox calculation. That is even more challenging, because that is your constraint, okay. Yeah, and you can see this is the basic transmission parts, which has the clutch shaft input, then the lathe shaft, the main shaft. From there you will go for gear shift levers, synchronizer, transmission case, shift forks and dog clutch. These are the components which are present in the gearbox system, okay. I think I will stop now. Tomorrow onwards we are going to do a actual automobile gearbox design aspect, okay. Thank you.